7.4. Evaluate logarithms. Now, you're very rarely going to hear me say the whole word. You're typically going to hear me say logs.
Calculators.
Logarithm.
Where's the R?
R-I-T-H.
Oh, it looked like an M.
All right. Definition of logs with base b. Let b and n be positive numbers. With b not equal to 1. The log of n with base b is denoted log base b of n. So it's like a little subscript with an n there, like beside it. And is defined as log base b of n is equal to p if and only if, no, I didn't spell if wrong, b to the p is equal to n.
Why is the b lower than the n? Like, I know there's a reason.
It's like a subscript.
Okay.
It'll make a, well, I feel like I always say it'll make more sense when you see it with numbers, but it's the base and that's a number that's changing and then n is something totally different. This is how, a log is how we undo an exponential. So
Okay,
the
I've seen this
exponentials
on
that
my
we just
calculator.
did, we're undoing this.
Is the where it says denoted, is that one word or is the D like a variable?
Yeah, it just is beside it.
Okay.
It's just really far over.
Okay.
I really like that.
Huh?
I moved it over.
Move
I
one
wrote it
over.
as denote D.
I did too.
Oh,
Sorry.
that's what I did.
I was just writing as you were saying it. So.
All right, so this first thing that I have this red arrow drawn to means or is said as log base b of some number n is equal to some power p. And you're probably like, why in the world is she saying it that way? This is going to be the same phrasing that I use with how it gets rewritten. This in green, or well, it's written in blue, but the green arrow says base b raised to power p
Where did my phone go?
is equal to some number n.
It's in my pocket.
Love it when that happens. Now, this is the way that it was taught to me with this phrasing. And basically, I was taught, like, you memorize it, you learn this phrase, or you're stuck. But when I was doing some student teaching, I was like, I want to find an easier way to teach this. And so I found this other method that I've been teaching, and I think people tend to find this to be a little bit easier. So I'm going to show you that. Hello. Do I not get to use other colors today? Okay, well, we're stuck with these colors. So, logs and exponentials are inverses of each other. So if I want to go from a log to an exponential, my little phrase is going to be make an e. So I would recommend you write what I'm about to say like one line down because we're going to be drawing around it. So we're going to write this log base b of n is equal to p. So if I needed to solve for one of these pieces and I didn't know anything else, okay? So like let's say I needed to solve for what n is equal to, because that's a lot of times what we're doing. Then the way that I do that is I start here at the base. I want everybody to look really quick and then you can draw it for yourself. Start here at the base. We come up and around like that and it makes an e. This goes into the form b raised to the p is equal to n. We start at the base, go around to what it's equal to, and come back through to the n.
That looks like a tornado. Cooper, I think you should get that checked out.
I did it. Me too. I'm not pretty good. Yours is prettier than mine, but look at mine.
Have you seen me? So further.
Now, if I'm going to go exponential to log, then we make an L. And it'll be like a capital L. So if I have b to the p is equal to n and I want to go the other way, y'all want to watch again? We start up here, we come down through the base, come over through here, and then up this way, so it makes like a giant L. And so we have log base b of n, so that's the next thing that we come to, is equal to p.
Wow.
So a lot of times when we get to, especially if we get into the word problems and stuff, you're going to hear me say make an L or make an E. And that's how we're going to rewrite them. Now, if that confuses you and you want to memorize these other lovely phrases that I wrote up here, have at it. That's how I had to learn it. But I really liked this visual model instead.
So you just write it in the order you draw it.
Yep. So if you have an exponential, you're making a log, you start with log. The first thing you come to is your base, then it's the number, and then you come back around, and the last thing you hit is always what it's equal to. So over here, we want an exponential. I have a log, that means I need an exponential to solve it. Start at the base, loop around, that's the power that's being raised to, and then we come back around and that's what it's equal to. That's the last thing that it hits. Some people just call it a swirl. I like to call it an E because I think then it helps you know like when I'm going to an exponential, I'm making an E. Now we have some, still not working. Okay. We have some like special types of logs, and so we have a common log, which is a log with base 10. So if you look at your calculator, you're going to see on the left-hand side over here, it's going to be you're going to see down here beside the 7 that there is a button that just says log. That is common log, or what we would call log base 10. So if there's no number written in the base, then that means that it's a log base 10 and that's the button that you would use. Okay? So this would be, you'd see it written like log of x, like this, which means log base 10 of x. The other type that's like a special one is the natural log, which is log with base e. Now, we don't write this as log base e. If you look right underneath the log button on your calculator, you'll see a button that says ln. So natural log is written as the ln of x. But what this means is log base e of x. Now, it's not wrong to write it this way, but the shorthand way and the way you'll click it on your calculator is this ln of x when we do a natural log. And lastly, for the notes, we have some properties of logs. The first one is basically, it's called the log of 1. So if we have log base b of 1, that's equal to 0. The reason is because if we started here, we have a log. So if I make an exponential, b raised to the 0 is equal to 1 because anything raised to the 0 is 1. So if you have this situation, this log base b of 1, it's always going to be equal to 0. The other option is if we have a log of b that is base b. So if we have log base b of b, that's equal to 1 because if we have a log, we make the exponential, b to the 1 is equal to b because anything raised to the first power is just itself.
What? The ln.
I know. It was illustrated earlier. That would have been a little messy, so don't make it funny.
Two other properties here. I was like, I know I'm missing 2 on my thing. Log base b of b to the x is equal to x. These things, if the base is the same as the number that's in here, then whatever the power is here is what it's equal to. Because b to the x is equal to b to the x. If the bases are the same, then their exponents have to be the same. And then the last one is b raised to the log base b of x is also equal to x because these things cancel. If you have a base raised to, or if you have a value raised to the log of that same base, then it's just equal to what's ever in here. It doesn't matter what this is. Like a lot of times one of the questions that you're going to get is going to be something like 8 to the log base 8 of 3 is equal to what? 3. Nice and easy. And that's how easy those can be.
Yes. Can these be difficult?
Huh?
Can these be difficult? If I ever do see this.
Not really, to be honest.
It's fun.
How do you just think about it?
Overall, not really.
Went to college for that. So it's gonna have to be difficult.
Most people like these.
Okay. Perfect.
Well, this is what the-
You like
All right, I'm actually